all of the classifications for naming. We went over 2. So we've already done 2 of the 3. Do what? In the other room? Okay. Did you figure it out? Did anybody else go in there? No, really, I didn't even take a chance. We just moved, so. Yeah, that's fine. We'll call IT and. Okay. Okay, so the first thing that we do when we're naming compounds, we are going to look to see if we have 2 nonmetals, or if we have a metal and a nonmetal, or if we have a transition metal and a nonmetal. Okay, so we have 3 different classifications. The first one is, to me, the simplest. Okay, we also, before I move on, we call nonmetals are also anions. So if you see that, it's the same idea, because nonmetals form negative charge. Okay, your metals, you'll sometimes see them called cations. Okay, so we've already discussed that previously, so hopefully that makes sense. Okay, our first classification, so we're just going to review real quick. We use the Greek prefixes. Okay, and so this is for nonmetals only. Okay, so there's really only one classification for nonmetals, or for covalent compounds. Okay, and so we're going to use the Greek prefixes. So if we have, 1 atom, we say mono. If we have 2, it's di, 3, tri. Okay, so let's name this compound quickly. We did this on Monday. Okay, so we would say diphosphorus, and then you would use the prefix for 5, so pentaoxide. Okay, technically you're supposed to drop that A in penta and say pentoxide. Okay, so that's the way that we would name the nonmetals, or for P2O5. Okay, if we write the formula, we just have to know the prefixes. It's the same idea. Okay, so if we have arsenic, we would have AS4, because tetra means 4. And then we would have hex oxide, so that was hexa. So that means we would have 6 oxygens. Okay, the kind of trend here for actually all the classifications until we get to the very end, we end in IDE. Okay, so you drop that ending on oxygen or whatever it might be, and you say IDE. So oxygen becomes oxide. Okay, our group 1, 2, and 3 metals. Okay, why they're classified separately from our transition metals is because we know the oxidation state on those all of the time. We know the oxidation state of the group 1, 2, and 3 metals, and it's always the same. Okay, so these group 1, 2, and 3 metals, these are your group A metals. Okay, so these are your representative elements. Okay, so if you have your periodic table, I don't even have a big one in here to pull up. Okay, so if we're in group 1, for our group 1 metals, our alkali metals, okay, all of those metals in group 1 form a +1 charge. Okay, also, don't get confused when we use the word ionic charge, oxidation state, or formal charge. All 3 of those mean the same thing. All 3 of those mean the charge that the metal forms when it loses an electron, or 2 electrons, or how many ever it loses. Okay, so your group 1 all form a +1 charge. Okay, for group 2, your group 2 metals, your alkaline metals, form a +2 charge, always. So it's understood that we know the oxidation states of these metals. Okay, group 3 over here. Okay, so really boron's on the other side of the stair step. So aluminum is really where it starts. Okay, so your group 3 metals form a +3 charge. Okay, so hopefully that's a review. So what we can do when naming the group 1, 2, or 3 metal and a nonmetal, okay, for the naming of it, it's really simple. We don't use prefixes. We don't have to use any Roman numerals. We'll get to those here soon. And all you do is you say the name of the metal and the name of the nonmetal ending in IDE. Okay, so you don't have to say di or tri or whatever it might be. Okay, so for this one here, it would be aluminum sulfide. That's it. Okay, it's not dialuminum or trisulfide. Okay. Also, you'll want to kind of, as I'm going through this takes practice. So when you'll kind of come across little hints or tips. So I'm going to try to give you those as we go through. So when you're working your homework, maybe it'll help you to keep the classification straight. When you're writing formulas, and this holds true for all the classifications and everything that we do for naming, for you guys anyways, for writing the formula, we can do the swapping of states all the time. Okay, so on all the classifications, when we write the formula, we have to know that our total ionic charge must be 0. Okay, so our total charge and our final compound must equal 0. This becomes really important for the third classification. Okay, but it's just a trick. It's a way that it works. You can look back at electron diagrams if you want to that we went over in Chapter 7, and you will see that it works every single time. So we can pull apart, so we have our metal, and we write the oxidation state. It's a +1 because it's in group 1. Okay? Sulfur. Okay? We didn't talk about our nonmetals. Okay? If we go over here, our noble gases, they are unreactive. Okay? So they don't have an oxidation state per se. Okay? But your halogens, which are right next to the noble gases, they form a -1 charge. Okay? Hopefully this is a review. Okay? And then your group 6, a -2. And then your group 5, a -3. Okay? And we really don't deal with carbon and silicon in this class, okay, because they don't really like to form charges. Okay? So we write out the charge, and then we just swap the numbers. Okay? So this 2 goes here, and this 1 here. And it's understood that that's a 1. You don't have to write it. You can if you would like to. Okay? And so this works because we're canceling the charges, which we know our ionic charge has to be 0. Okay? So when we're writing the formula, we can swap charges. And it's just a shortcut. Okay, so we left with these, with the practice for these. So if we're going to, let's do the easiest one first. Let's name the compound. Okay, so we'd have to look at our periodic table if you didn't know that Mg was magnesium. Okay, and so you would write out magnesium chloride. That would be the name for this. Okay. I think when I touch computers, they just don't work, apparently, because this one's not working now. Perfect. Okay. Get my pen out. All right, so the name would be magnesium chloride. All right. For writing the formula, okay, for all of when we're dealing with metals, okay, we can write the formula by just pulling it apart, writing each oxidation state, and then swapping the charges. Okay, so if we look for sodium chloride, we have to know the symbol. So what's the symbol for sodium? Okay, Na. Okay, it's in group 1, right? So it's got a +1 charge, oxidation state, same thing. Okay, and then we have our chlorine, which has a -1 charge. It's a halogen. It's 1 electron away. It wants to gain 1 electron to be like the nearest noble gas. Okay. When this happens and you have a +1 and a -1, so you have the same charge, basically those just cancel. So +1 -1 equals 0. Okay, and so, or you can swap the 1 here if you would like. Either way, but you end up with a 1-to-1 ratio of sodium and chlorine or chloride. Okay, what did you guys get for magnesium bromide? Okay, so if we look at magnesium, okay, it has a 2+ charge, right, because it's in group 2. And what is the oxidation state of bromine? minus 1. Okay, and so then we just swap the numbers. We don't move the charges. We can't have a negative atom. Okay, and so we end up with MgBr2. Try this one more time. Okay. All right, the last one. So we've got magnesium again. So we've got Mg2+. All right, now we have oxide, which we know is from oxygen. Okay, so what's our oxidation state for oxygen? 2-. Okay, so once again, we have this 2+, 2-, so basically this just cancels out to be 0. Okay, so if you were to write this, okay, technically that is not correct, okay, because this is, if you were to divide by the this is a ratio, so if you divide by 2 and 2 here, you get 1. Okay, so you really, if you've got a +2 and a -2, you just want to write it out as so. And you guys will actually do this in lab. You'll come up with the formula for magnesium oxide. Okay, now to our third classification. Okay, we've looked at nonmetals, group 1, 2, and 3 metals and nonmetals. And now we have to learn how to name transition metals, and these also include tin, antimony, lead, and bismuth. So everybody find those on your periodic table. Okay, they're all grouped together. Okay, so tin, antimony, lead, and bismuth. They're all this like a square right down here towards the bottom of the periodic table. Okay, so this classification, those are the elements or the metals that are included. Okay, there are exceptions. So zinc, cadmium, silver, there are exceptions that in the fact that they always have a +2, +2, and a +1 charge. Okay, on the contrary, transition metals and the other 4 listed here, they have variable charges. Okay, that means that we can't say 100% that all the time copper has a 2+ oxidation state. Okay, that's what makes these guys different. That's what makes studying these can be even complicated. There's whole courses on just one element. And yeah, because they can do lots of different things because of this. Okay, but for right now, you just want to know that their oxidation state can be here, it could be +2, or it could be +1. Iron could be +2 or +3. Okay, and so we have to find out what the oxidation state of these metals are. Okay, it's not understood like group 1, 2, and 3 metals. They're always 1, 2, and 3. Okay, but these are different. Okay, so what we do is we have a Roman numeral in the naming. Okay, this Roman numeral, okay, is the oxidation state of the metal. Okay, so we're going to look at how to find this here in a second. Okay, so if we look here, we have a +2 oxidation state on copper, and that 2 right there corresponds to the oxidation state. Okay, it is not the number of atoms. Okay, I want everybody to say this with me, this whole sentence right here. Okay, this is the most messed up part of naming ever. Okay, the Roman numeral is the oxidation state of the metal, not the number of atoms. Okay, so it is the oxidation state. Okay, so here's just some. This doesn't include all of the transition metals, obviously, but these are some of the more common of the metals that have more than one oxidation state. So here you can see the exceptions. They're right here. Okay, if you look over here, all of these are consistent. They're always 1, always 2, always 3. Okay, but here it varies. Okay, so this is just showing you visually how this is going to work. And then if we look at our nonmetals, they're consistent all the way through. Okay, these guys not consistent. Okay, so the hardest one really. So writing the formula is going to be pretty easy. We're going to do the same thing. We're going to swap charges. Okay, naming is typically, this is the most complicated of the three classifications, okay, because we have to find out what the ionic charge or the oxidation state is of the metal. Okay, so this is where earlier I said it becomes really important that we know that the total charge of our compound when we name it has to be 0. Okay, it has to be neutral. All right, so we're going to have to, it's very simple math, so it's just a matter of knowing when to do it and doing it when you're looking at, picking out when the classification includes this. Okay, so here we have manganese. Okay, so here we're given a formula. Okay, and you have to write out the full name. Okay, so the first thing that you've got to do, okay, if we look back here, sorry to go back, but if we look here, when we name, we have to write out the name, and then in parentheses, we have to put the oxidation state. Why? Because someone needs to know, what is the oxidation state? It could be 2 or 3 or 4. Okay, we don't know. Okay, so that's what we're coming up with first. We've got to find out what goes in that Roman numeral. Okay, so this is an example. So we know that our nonmetal, we always know the oxidation state. So it's really just a process of solving for a variable. Okay, so we know that we have, in our formula, we have 2 atoms, and we know that fluorine has a -1 charge. Does everybody agree with that? Okay. However, in our formula, we know that we have 1 manganese atom. Okay, so we bring that down here. But we do not know the charge. Okay? So what we do is we set this equal to 0. So we're going to have whatever 1 times x, if you want to plug that in there, plus 2 times -1 has to equal 0. That's the key. If you remember that, it's not hard to find out. Okay, it has to equal 0. Okay? Another common mistake is to not multiply times the number of atoms. Okay, you have to be sure that you take into account each atom and its charge. Okay, so we have 2 fluorines. Okay, so what number plugged into here would give us plus or -2 equals 0? 2. 1 times 2 is 2. -2 equals 0. Okay, so that's how you solve for x. Okay, when you solve for x, this is the Roman numeral or the oxidation state of the transition metal. Okay, so our ionic charge must be 2+. Okay, so here's kind of a guide. We're going to go through and practice some of these. We have to determine the charge. That's the first thing. We have to determine the oxidation state of the transition metal. Okay, then we're going to name that cation or the metal, and then in parentheses, we're going to put that charge. Okay. And then the ending is just like we've been doing. You place the ending, the anion, which is our nonmetal, and you end it with IDE. Okay, so we're going to walk through. Okay, I know it's up here what the oxidation state is, but we're going to be sure we know how to find it. Okay, so the first thing we're going to do is we're going to look at our formula. So we're trying to name FeCl2. Okay. So basically, that's our X. We don't know the oxidation state. All right. For our chloride, we know that it's always -1. Okay. But the thing that we can't forget is we have 2. We have 2 chlorides. Okay. So if we add up the charge, we have 1 iron atom in the formula. So we have 1 times X, which is what we're trying to find, okay, plus 2 times -1. Okay, that -1 comes from here. So you have to multiply the number of atoms times the charge, and this has to equal 0. Okay, so this is a pretty simple one again. Okay, so 1 times 2 will give us 2 minus 2 equals 0. So X, or the oxidation state, has to be 2+. Anybody need me to do it over here so you can, could y'all see all the way over there? Not really. Okay, don't need me to do it over here? Okay. Okay, so that's the first thing. That's really the biggest difference in the classifications is we have to come up with the oxidation state, okay? And then we're going to name it. So we're going to name our first atom. You always name your metal first and then the nonmetal. Okay, so we have iron, and now we know that in parenthesis we have a 2. Okay, and that 2 stands for the oxidation state that we just found. Okay. Then we know that Cl, the element symbol, is chlorine, so it becomes chloride. And so our final answer here is iron 2 chloride. Okay. So when you see this, anything that's named this way, if you see these parentheses, it's automatic that you should think of transition metals, okay, because that's the only name that we include the Roman numeral. Okay, so I want you to take a second and name these 2 compounds, and we'll go over them. Okay, the first thing we have to do is if all these were jumbled up, so all the classifications and compounds are jumbled up, the first thing you want to do is recognize if you have a metal and a nonmetal, or do you have 2 nonmetals. Okay, it's obviously we're talking about classification 3, so we have metals. Okay, and we also, not only do we have metals, we have transition metals. So this is where you want to automatically think classification 3. Okay, the first thing that we have to do if we're going to name these is we have to come up or find the ionic charge. Okay, so if we look here, we've got 2 atoms, okay, and we don't know at X, we don't know the oxidation state, and we have 3 oxygen atoms. So it's just a process of elimination, really, because we know the oxidation state on oxygen is always 2 minus. Okay? So if we put this into 2 times x plus 3 times negative 2 has to equal 0. Okay, so if you want to solve for x and rearrange, however you want to do that. To me, I just look at it. These aren't going to get very complicated. They're going to either be 1, 2, 3, or 4. Okay, so not too complicated. So if we solve for x, in order for this whole thing to be 0, x has to be what? What? 3. Exactly. Okay, so the oxidation state of iron is 3. Yes. Okay, you can do that majority of the time, but not always. It doesn't work. Yeah, you'll run into situations that won't work. That's why this is the only one that we go through this for, because it doesn't work 100% of the time. So yeah, it will work a lot, but not all the time. Okay, so we're going to say iron, Roman numeral 3. All right, we have oxygen, so we know we just drop the ending. Iron 3 oxide. Okay, for this one, we have one atom, 10, and we have 2 chlorides. So we would say 1 times X plus 2 times -1 equals 0. So X has to equal 2. So we would say 10, 2 chloride. Yes. Yep. You have to account. So 1 chloride has a -1 charge. So if you have 2 of them, you have to account for that other chlorine atom as well. Yes. Yeah, it doesn't matter. I'm not that picky. So you can, technically, if you want to capitalize this but don't capitalize, it's all one word pretty much. So you can just leave it either way. Okay, so that was really the more complicated one. We're going to plug in some different ions here in a few minutes. But as far as, let me bring this down. For writing the formula for classification 3. So now we have named, okay, which is going to took us the longest. Now we're going to write the formula. Okay, well, if you're given the name of a transition metal, or an ionic compound with a transition metal, if it's the proper name, it's going to give you the oxidation state, right? So if we look at this name here, 10,2-bromide, okay, that 2 stands for not the number of atoms, it stands for the oxidation state. So it's given to us. We don't have to go through any calculation to figure it out. So it works just like we've done before. Okay, we would take our 10, 2 plus. Okay, so we get that 2 from the name. Okay, we got these numbers earlier from group 1, 2, and 3 just based on the group that they were in. Okay, and then we take our nonmetal, have a -1 charge, and then we just swap the numbers. Okay, so we swap the states and we get the final formula for the compound. So this is identical almost to the way that we have written formulas on the last classification. Okay, and this is less complicated because we're given the oxidation state. It's going to be part of the name. If I don't give you that, then it's a typo because that is part of the name. Okay, so a couple more practice problems here. Okay, let's start over here with write the formula. Okay, so we look up, we see on the periodic table, if we didn't already know, the symbol for copper. And we're given the oxidation state. And we know that the oxidation state for iodine, now iodide, is -1. Okay, and then we just, when we're writing formulas, we just swap states. So this would be our formula. Okay. For zinc, we're given it has a 2+, and oxygen, or oxide here, has a 2-. Okay, and so here the +2 and the -2 cancel each other, so we don't really want to swap them there. They're the same number, so we end up with the smallest. You want to write the smallest whole number ratios there. That's why you wouldn't want to put zinc 2, O2. Okay, is this what everybody got on these? Okay, what did you guys get for naming of NiBr3? Okay. Nickel. We have 1 atom. We have 3 bromides. All right, our X has to equal 3. So we would write out nickel, Roman numeral 3. Bromide. Okay. We have 1 tin atom and 1 oxygen atom. So X has to equal 2. Everybody get 2 for the oxidation state? Okay, so we'd say 10, 2. Okay, Anderson, this would be an example where it wouldn't work. What you're thinking? All right, does everybody feel pretty good about those, the 3 classifications? Okay. We're going to introduce polyatomic ions. Okay, there you can take one and pass. I didn't print off whole 60, but these are in your book. So if you've got your book, they're also online. So if you've seen them on Blackboard and have them, but just if you can share or whatnot. Yes. No. My first semester, they had to memorize quite a few, but you can always find a list of these, so you're not going to have to memorize them. Okay, with saying that, that doesn't mean that you do not need to you just need to put it to the side and never look at it, okay, because you're going to get confused. You need to become familiar with polyatomic ions, okay, and so we're going to talk about what they are and all that here in a second. Okay, the biggest difference whenever we introduce these into naming is that students want to start changing the rules and start thinking about different things, okay? It's the same rules, okay? Rules 1, 2, and 3, or our classifications 1, 2, and 3, still hold true with the polyatomic ions, okay? So it's just, we have one little bitty difference, and you just have to be able to recognize the polyatomic ion, okay? So when you get your list, I want you to look over it. So I think it's way back there now, but we have a group of atoms that bear a charge, okay? So that's kind of the difference here. Okay, so I just basically said what's up here. Okay. Polyatomic ions are a group of atoms that have an overall charge for the whole group, okay? And they usually consist of nonmetals. So your oxygen, sulfur, carbon, nitrogen, and oxygen are typically the elements that are used for polyatomic ions, okay? They usually have a charge of 1-, 2-, 3-. Okay, there's one polyatomic ion that has a positive charge, and that's ammonium. And it's the only one, and that was the first one on this list that I have handed out. Okay, so here's a list. It doesn't include all of them, so I've tried to include most all of them on this list. When you start to name these, you'll want to look at the list and be sure. I think all of them should be on there for you guys. Okay, but as you see here, so they're pretty hard to memorize. So if you were to try to sit down, because you've got nitrate, nitrite, chlorate, chloric, it gets confusing because they're all so similar. Okay, so I've kind of broken it down into kind of some groups. So your most common polyatomic ions end in ATE. Okay, so sulfate, phosphate, and nitrate. Okay, so I want you to notice here, this charge, that's the oxidation state of that whole group of atoms. Okay, just like we were looking at metals and transition metals had a charge, these do as well, but it's for that whole group of atoms. Okay. If you have one less oxygen, so look up here, we have SO4, we have 4 oxygens. Well, then we go down to 3. Now everything ends in ITE. So we have sulfite, phosphite, nitrite. So that's kind of a consistency. Some things aren't consistent, but for these, that kind of helps when you're trying to look at these and if you were to have to memorize them. Okay. We're going to first look at writing the formulas. So as I said earlier, writing the formulas for all of our ionic compounds, for all that you guys are going to do or work on, we can swap states. We can do our swapping of the ionic charges here. Okay. So we use the same rules. The biggest thing is that you have to recognize that it is a polyatomic ion. Okay, so a lot of students will see, so I would give you a formula. Say I gave you magnesium nitrate. You have to recognize that that doesn't end in IDE. That's not nitride. Okay, it's nitrate, which is a polyatomic ion. So you're going to get your list, and you're going to go find it. Okay, and you'll see that it has nitrate includes 1 nitrogen, 3 oxygens, and it has an overall -1 charge. Okay, so does everybody have a list at this point and see that? Do what? Okay, do you have a book or anything that would have it? Yeah, your book. I don't know what page it would be on, but or try to share if anybody can pass some back. Okay. When you look at your list for nitrate, it has a -1 charge. Okay. For magnesium, okay, this is a group 2 metal. Okay. So we consider this polyatomic ion to be an anion, just like it was for the nonmetals and the group 2 classifications. Okay. So we're going to name it, so we're going to write the formula and we're going to name it the same way. We just are plugging in a polyatomic ion. Okay, so we take our magnesium 2+ charge, it's in group 2, and then we recognize that nitrate is a polyatomic ion, because you guys are going to look over this, study this, and be able to recognize it right away. And it has a -1 overall charge. Okay, so to write the formula, all we're going to do, you can calculate it, I have that here if you want to, but the easiest way is just to swap these numbers. Okay, so you're going to bring this 1 here, and this 2 here. Okay, notice that we have parenthesis around this. Okay, you must do this. Okay, if you swap that 2 over and it looks like this, that's a misrepresentation, right? That looks like we have 32 oxygens. Okay, we put it in parenthesis because it's telling us that we have 2 atoms, 2 polyatomic ions. This whole group, we have 2 of them. Okay, does that make sense? Okay. Okay, so I'm going to do the first one. I'm going to have you guys do the next 3, and we'll go over them. Okay, we have aluminum nitrate. So I would give you this name. The first thing you want to recognize is you have a metal, and you have a group 3 metal. So you want to think classification 2. However, you have nitrate instead of oxide or one of our nonmetals. Okay, you have nitrate, which is a polyatomic ion. Okay, so you would go to your chart here. Can you guys even see over here? You guys know. Guess I'll lift it up again. Okay. So if we're going to write the formula, we're going to write out aluminum, and it's in group 3. Okay. And then we know that we have nitrate. So you go and you find nitrate on your chart, and it's NO3. Okay, so the whole polyatomic ion has a -1 charge. Okay. So then we swap our states. So we end up with it's very common for students to accidentally forget this 3. Okay, remember, you have to include the whole polyatomic ion, and now we have 3 of those in the formula. So number 3 up here would be our answer there. Okay, the next one, probably can't see it. Okay, we'll do this one together too since it's a transition metal. Okay, we have copper. Okay, so we're going to write the formula. We know this is a transition metal because we've got this Roman numeral here. Okay, so we know that copper is Cu. This 2 means that our oxidation state is 2. And then we have nitrate again, I believe. Yep. So we have NO3 minus. If it helps you to put all of these in parentheses just to keep them bunched together, actually suggest that just so that you don't start forgetting this number, or be sure that you keep the polyatomic ion together. Okay, if we swap, bring our 2 here and our 1 here. Okay, so it looks like this one. Okay, we've got iron. That's 3. Okay, hydroxide is the second one on the list that I have. Okay, so you would want to recognize, like I said, be familiar with this list. Okay, hydroxide is usually one that a lot of students do memorize or remember. Okay, it has just a -1 charge as well. Okay, and if you want to put the whole thing, so it's a OH. Then we swap our numbers, so 1 here, 3 here. Okay, and for the last one, we have a transition metal again. So we have tin, 4, and hydroxide. If we swap our numbers, we end up with this. Any questions on these? Okay. And the last thing we're going to look at, we're still using our same classifications, but we're going to look at naming with polyatomic ions. Okay, I will give you, this is just kind of a tip, the way I think of it. I'm still using all of the rules, all the things that I've been looking at so far. And if I have to use a Roman numeral, I use it with a transition metal. Okay, if I have a group 1, 2, or 3, I don't. Okay, so the naming is similar. The only difference, this is the only time that you don't add IDE. Okay, so think about it. If you have nitrate, is a polyatomic ion that we've been looking at. Okay. Nitride looks like this. They're two totally different things. So if you turn nitrate into nitride, then you're misrepresenting the polyatomic ion. Okay, so you just end whatever the name is on this sheet, you write it exactly as it is. You don't change it. Okay? That's really the only difference for these. Actually, never mind. Go back up. Okay. Let me erase real quick. Okay, so look at these and start to think how you would, well, the name's already up here, but go through and see if you agree with how these are named as I erase everything here. Okay, so now you're given a formula and you have to name it. Okay, remember the hardest one of all of the classifications, I feel like anyways, is when you have to name the transition metal. Okay, everything else is pretty straightforward. Okay, this one is a group 2 metal. Okay, so if you go back to the classification 2, how did we name those metals and non-metal? Do I remember? You just, that's a good, she just straight named them, that's what you said. Okay, so you named the metal and then you named the non-metal. Okay, except for we ended in IDE. Okay, but here we have a polyatomic ion. Okay, so you see this parenthesis, that's a key right away that that group of atoms is a polyatomic ion. Okay, so you go and you find it on your periodic table, or not your periodic table, but your list, and you see that NO3, on the one we've been doing, is nitrate. Okay, so you just name it as that, calcium nitrate. That's it. Okay. The only difference is we have a polyatomic ion, so we don't have IDE. Okay, for a transition metal, this is our classification 3, where we have to use a Roman numeral, right? Okay, but this time, instead of having just an oxygen or whatever we might have there, we have a polyatomic ion. Okay, so we go find PO4 on the periodic table, okay, and it is phosphate. Okay. And you also see the charge. I keep saying the periodic table. I'm used to saying that all the time. Go to your polyatomic ion list, not the periodic table, and it has a 3- oxidation state. Okay, so from this point, we have to calculate our oxidation state of iron, just like we've been doing, except for we have, instead of just a non-metal, we have a polyatomic ion. Okay, so we would say that we have, so we don't know this yet. Okay, we don't know this yet. We're looking here. So we have one iron atom, and we are looking for the oxidation state. Okay. How many phosphate atoms do we have, or molecules? 1, exactly. This is where a common mistake, and students want to use that 4. Okay, that is, we have 4 oxygens in this total group. Okay, but we have 1 polyatomic ion. Okay, so we'd have 1, and then we found our charge on our list, which is a 3-. So we have 1 times x plus 1 times -3 equals 0. And so x has to equal 3. Okay, so we say iron 3. We just found it just like we found it earlier. It's the same idea. You just have a polyatomic ion there instead of a nonmetal. No, that's part of that group. Yeah. One way you can recognize, too, everything we've been looking at so far has just been 2 atoms, okay, because y'all are not going to name atoms larger than what we call binary compounds. Okay? When you start seeing more than 1 type of atom in there, automatically you want to think of a polyatomic ion. There's got to be one, because everything we've looked at so far has been iron and oxygen, or tin and oxygen. There's only been 2 atoms involved. types of atoms. Okay, so this is, here we've got 3. So you automatically want to think of polyatomic ion. Okay, and then we write out phosphate. We write exactly as the list tells us what the polyatomic ion is called. We don't add IDE or anything of that nature. Okay, I think these might be the last 3. It actually walks through them, but okay, go ahead and name A, B, and C. And I'll write them out up here in case you can't see them. Where? Did it have the wrong? Oh yeah, that is another. Is it not on the list? None of those are. I thought I updated it. Yeah, I'll post an updated list, but that is phosphite. Yeah. Yep. So if you look, yes. ITE. So I'll go right here. It's PO3, 3 minus. Yeah, sorry about that. I updated. I must not have saved it because I noticed that last semester. Anybody have the list printed from Blackboard by chance? Is it on that one? Okay. I know I updated it, but I guess I didn't save it. Do I? Yeah, no, it wouldn't be. I don't know what I did. I think there's one more that's not on there, too. I'll have to go back and look. Yes. It's phosphite is the name of it. It's just missing from the list. Yeah. Okay, so see if you got something similar. We'll walk through these. If you can see, but okay, so A and C we're naming using the transition metal or the classification 3. So this is where we have to solve for the oxidation state. Okay, so B is the easiest one because we have a group 2 of metal. Okay, and then we look here in this parenthesis right here that pretty much just tells us right there that we have a polyatomic ion. Okay, so if this one was on your list, then you would go find it, and it's phosphite. Okay, so that's what I have over here. Okay, and so the name is barium phosphite. Okay, we don't use Greek prefixes, we don't use Roman numerals, we just name the metal and we name the polyatomic ion. Okay. Now if we look at A and C. Okay, so we have to solve for this here. And then once we do that, it's pretty easy from that point. Okay, we have 2 iron atoms and we have 3 sulfate atoms. And our charge, we would go to our list, and we have a 2- charge on sulfate. Okay, so if you want to do this, help you there. Okay, so 2 times x plus 3 times -2 has to equal 0. Okay, so x has to be 3. 2 times 3 plus 3 times -2. So our x has to be 3. So we have iron 3, and then we just name the polyatomic ion as it's written on the list. So we have iron 3 sulfate. Okay, for lead carbonate, lead 2 carbonate to be exact. So we have 1 atom of lead. Oops. Okay. We see here, so this one's a little harder to see. Usually, because we just have 1 of this polyatomic ion, this is where students will try to use that 3. Okay. So we have 1 polyatomic ions. If that helps you to go ahead and go through and put those parentheses around, definitely do so. Okay, so we see that we have another thing that kind of tells us we've got a polyatomic ion is we have 3 different kinds of atoms here. And all the other ones we've been looking at, we've just had 2. So we go to our chart, we see that this is carbonate, and it has a 2- charge. So 1 times x plus 1 times -2 equals 0, so x has to equal 2. Okay, Pb is the symbol for lead, so we have lead 2 carbonate. Okay, so the only difference is we're just plugging in polyatomic ions for the anion portion of the name. Okay, and so you just write that name as is. Everything else holds true for classifications 1, 2, and 3. Yes?
How come the charges cancel out some of lead carbonate?
That's when you're writing the formula. So we did this backwards. So if we're going from the name to the formula, see how these canceled to give us the formula? Okay, that's for writing the formula. But when you have to name it, we have to know the oxidation state. So we plug it in there.
Barium phosphide. I got barium 3 phosphide.
Okay, yeah, but you're trying to write the formula. We're naming. So we're given the formula. You're doing it in reverse. So we're given the formula and we're trying to write the name. Now, if you were doing it backwards, that's a good way to practice to be sure that the name that you've given here. So if we do this backwards, we have Pb2+, carbonate, like so. Our charges cancel, and this is what we get. So we named it correct because they both match up. Yeah. So they cancel when you're writing the formula, not when you're writing the name. You're trying to find this. You're not trying to swap or do anything. You're just trying to find that number there. Yeah. Any other questions? Okay, over the weekend you need to work on the naming worksheet. Who has been working on it? Hopefully all of you. Now you know all of the different ways. Okay, and it's a long worksheet. So come Monday I'm going to go around and look and see if you guys have been practicing. Bring questions because this is the beginning of the unit. Come the end of the unit, you're going to forget what we learned today and yesterday, or Monday. Yes. Yes, and I will put an updated version of the polyatomic ion list up as well. You guys have a good day.